We have here a box of 20 chocolates. There will be 5 caramel, 7 mint, and 8 strawberry. Can I write the breakdown below also to help in the calculation? 5 are caramel, I indicate as C. 7 are mint flavored. 8 are strawberry flavored. John is going to select 3 chocolates. Can we find the probability that exactly 2 of the 3 will be mint flavored? So they are only looking for mint. You should consider just mint or not mint. You don't have to think about how many are caramel or S. Just think about how many are mint or not mint, for which this is 7, this is 13. The thinking should be with a tree diagram, but it's optional to draw. Okay, I should write here first, optional tree. You can visualize in your head if that's possible, because drawing the tree is very long. But how should we think through? You want 2 of the 3 to be mint. The breakdown here on each branch is the different chocolate number. Then my tree has mint or not mint. Which are the branches you want? Can we do a highlight of them? I want this path, because this path has 2 M's. As long as you have 2M and 1M prime, you want. Or you want this path, also 2 M's. Or the last path here, also 2 M's. All these paths have got 2 M's and 1 M prime. I'm going to list down my cases. So first one is M prime. Second. And third, these are the 3 cases that we have seen. I show you the long way first before we try to shorten our solution. So each M, first M is 7 out of 20. Okay, remember M is 7, M prime is 13. My second M, it will drop by 1. So 6 over 19. Last M prime denominator will be 18 because you have removed 2. And M prime, you have 13. Now, second case, we continue to add. So we do 7 over 20. 13 over 19. 6 over 18. And last case. Oh, my bad. Thank you. Third case here, right? Third case here is M prime first. So third case starts with M prime, which is 13, 20, 7, 19, and 6, 18. We add up the 3 cases. However, I also want you to observe that if you look closely, they all have the same denominator as well as the same numerators, just in a different order. Your numerators don't change. So actually, you should do it in one step. This above is too long. You shouldn't write 3 cases. We should collapse to just 1 case by writing the following. Okay, can I just say the required probability? I just take 1 case first. I know it's a times 3 because I could see from my tree that there are 3 cases. But let's say I didn't construct the tree. I did mental calculation. How do we know that there will be 3 cases? This is actually the same as you do 3 factorial over 2 factorial. Because your 3 cases are actually, the difference is this M prime is on a different position. You are trying to permute your 3 objects such that you have 2 identical objects. So how many ways to permute 3 objects? Will be 3 factorial, and we divide by the repetition, divide by your 2 factorial. That's why you have 3 cases. It's actually because it's permuting. We are trying to count the number of paths on the tree by permuting your M m and m prime with two identical objects. Okay, or the tree diagram solution, you put a factorial at the back is always to count your paths.